Four terabytes, you are talking about 8 laptops. And we need 7 different locations to take care of its, in terms of emergency and then to retrieve it. So we are talking about 7 into 4, so about 28 terabytes. And 28 terabytes, as it start analyzing it, it becomes 5 to 8 times at the minimum. So 28 into 5 to 8 times, we are talking about huge amount of data. All in the cloud, one person's. So, and if you start exploring and try to see the life of the person, then try to explore how the whole, the enzyme biomarker expressions are going on, then we are going to be talking about huge amount of data. That's a challenge in research as such, right? Next slide. So it's already started to impact our medicine, the way we are looking at medicine. We have got some 2000 genes are responsible for certain health conditions, but more is being constantly seen about, the recent one talks about close to about 5,000 genes could be associated with various health conditions. Next slide. What is new to genomics? As I mentioned, it's the diet and the gene interaction, right? Study of how the genes respond to the diet and how diet impacts the genes. Next. And it's so interesting. We are not too much different from each other. Right? I think there's a lot of difference between one of us and another. 99.9% of all of us are same. So this is all of us are one, right? And all that we see as a phenotypic difference is just 0.1%. So, and the beauty of it is we are only double or slightly different from a worm, 50% different from a worm. So the genomic climax was that it really was an anti-climax. It said that we are not too very complicated as compared to a worm, as your worm has got half of what you have. So you think a worm is bloody dead, right? But not. And so not the goal. The goal is to keep learning. There's a saying in Tamil, my mother tongue. It says, "Katrathu kaimannalavu, kalladadu ulagalavu." What you learned is just the grain of sand that you have taken in the hand. What you have not learned is as big as the world by itself. So, but the journey well begun, the journey that is carried out with conviction, as Dr. Andal said, carry it on with conviction, and then it will definitely lead you to something good. So that's the walk into the future. Next slide. So these are possibilities where nutrigenomics people think that there could be a this is my genetic variant, and do you have a product for me? So it's personalized delivery systems, personalized medicines, and things like that. Next slide. So coming to the vegetarianism and genomics next. Yeah. So this is somewhere between about 14 million years ago, the humans and the orangutans, diverged. 14 million years ago. So it's just a second of thinking about what happened 14 million years ago, and the closest, the chimpanzees, we are about 4.6 to 6.2 million years ago. Next one. Yeah. So the early ancestors started off with this kind of a food, the Ardipithecus ramidus. He lived in wooded forest. So his food was completely vegetarian. And from there, the Australopithecus again was eating little harsher, like Dr. Arias was saying, the coconut water, right? Unless you reached the coconut, you broke the coconut, and then you saw the water inside, you would not have gotten it. So the man had the kind of, or the ancestors had the kind of a teeth or the methodology to look at the dry coconut and then shake it and see that there is something inside the water, and then try to open it and then take the little bit of water, and they might have come to the conclusion, oh, there's water inside. So this whole system, the body system, must have evolved from there. So from the hard abrasive plant diet eating was about 3 million years ago, and as the man moved further and possibly discovery of the tools, stones, and stone-made weapons and things like that, the man had developed the method to kill and start to eat. Possibly it could be an evolutionary compulsion. We do not know. I do not want to get into it. But then this is the kind of evolution that the man had moved in. Right. The next slide. So one single genetic mutation made a set of people from Africa completely vegetarian. And we just have a look at that. That happened about 100,000 years ago, tentatively, circa 100,000 years ago. Next slide. So this is the gene. This is the gene FATS2 and FATS3. They expressed the delta desaturase, the delta 6 desaturase, from where we could start getting omega-3 DHA fatty acids from the seeds, from the plant seeds. Primarily, initially, it was all dependent on the fish. Even now, the proponents of fish, they say that DHA comes only from the fish, the best quality. But we have algal DHA. So the DHA to the fish possibly comes from the marine algae, right? That's one, right? And two, the mind, the people who took DHA had a greater, brain development. Is again a proposition made by some set of people, right? And there are proofs, there are evidences for everything. But this particular gene mutation made persons to be able to make. I have been a vegetarian since my birth, right? We've been okay. I don't think I'm mentally, retarded or anything like that. So I could come here and speak. So to that extent, so DHA is there, and where this DHA came from, I'm not taking fish. I've never taken that, and it's all from the seeds, and my body perhaps has the sufficient amount of delta saturase enzyme, so it was able to get converted. So this is one thing that also has allowed people to migrate, and there are some evidences of this particular gene that could be traced all over the world from this African population. Next slide. So also conjures well with the migration of people from the one part of Africa. And this is regarding starch digestion. Again, I liked when Dr. Harris spoke about the chewing and mastication and the saliva, the amylase enzyme. The amylase enzyme had gone through a number of different copies and different varieties, and people have, as they evolved, they had different capacity to digest the starch. The initial starch was a completely complex carbohydrate, right, of polysaccharides, and half of it, or majority of it, goes undigested, right. The undigested ones, the undigested carbohydrate had gone down into the colon, goes into the colon, and they get digested by the probiotics. The bacteria that live in the colon, they digest these probiotics. And these probiotics digest these complex carbohydrates, and that's how there's a further release of certain subcomponents, which also is possibly improving insulin sensitivity. So there's a lot of reading, lot of news, information pouring from the complex carbohydrate, how they have evolved, how our digesting capacity to handle these complex carbohydrates evolved. Next one. We see this AMI1 and variations of AMI1 in certain regions, right, where people have various starch content. So people people, we presume that the people in India have a great copies. A study is currently going on, so we would possibly be able to come out with more information sometime later. Next. The same is with the lactose intolerance. There has been, next slide. There's been, the general tendency is people lose the lactase enzyme. The lactase is the enzyme that breaks down the lactose into simpler carbohydrates. Therefore, it gets absorbed. And during childhood, we have abundance of lactase, no issues. But as we grow older, by 7 or 8 years, the lactase enzyme goes off, and that's how people develop the lactose intolerance. There has been a genetic mutation which allowed for persistence of lactase enzyme in the gene, and there's a set of population which had continued to have lactase persistence. So therefore, they are still able to digest the milk. That's one. So lactase persistence has been seen as the gene. And man also has started to make cheese out of it, those who had lactose intolerance. So there are evidences that says that the cheese has been there in the Neolithic period, in the parts of the Neolithic period. So possibly the agriculture and rearing of domesticated animals, milk and milk products must have evolved at that point of time, right? Somewhere, the experts can say how the evolution scientists can say, I'm not an evolution scientist, somewhere at that point of time this should have happened. But there are quite a number of adults who have lactase persistence. Next slide. Next one. Yeah, move on. So we also know that bioactive food components can modify the genetic transcription, as we discussed earlier. Next one. This is an example for selenium, which has got multiple rows, micronutrient. Next one. This is interesting. Talks about the soy milk and the cancer incidence, breast cancer incidence. Yeah. Go back. Just would like to have a. So this selenium is basically a simple micronutrient that is part of the present in very straight quantity in the soil-rich foods. And all soil-rich foods have it. So you don't have to take selenium supplementation, right? And the role of selenium on the gene has been, reasonably characterized, right? Selenium gets methylated, and there is another sub byproduct called selenomethionine, which is capable of reaching the gene, and the gene talking between selenomethionine and the gene is far greater, and it has numerous implications on opening up the new blood vessels and the natural cell cycle death, right? The exact role in certain areas is not very clear. There are evidences that the tumor suppressor activity is pretty good for selenium. That is one of the reasons the mechanism was proposed, that the selenium's antioxidative capacity is possibly contributing to its tumor suppressor action. So these are some of the facts that we know of about selenium at this point of time. But there is a lot more to understand selenium-derived enzyme systems in the body. There are at least about 16 different types of enzyme systems. Not all of them are well characterized. Right? Next. And this is an interesting study on soy. And we know that the people in Japan take soy milk. And the soy milk intake, right? Higher the soy milk intake, the lower was the incidence of breast cancer. And you can see in the United States where it's low, it's pretty high, right? In India, we do not take soy as much. It's still not become popular, or it's still not very widely being used. India, for whatever unfortunate thing or whatever it is, whether you call it fortunate or unfortunate, for a many years, there is a huge population. At least that's what if you go back to our you can say our belief systems or our ithikas, right? All of them talk about how the cow and cow-related, the dairy products are used and how humanity evolved around it. So at this stage, we do not know about the Indian genes, how they have acted with the milk, right? Is that the casein has got a role to, it has a role on this increasing incidence of cancer, despite India being a largely and vegetarian society? We don't know. The reality, we don't know. We know one thing. We see hundreds of studies and hundreds of new studies coming out saying that a non-vegetarian population shifted to a vegetarian food has a tremendous value in terms of the cancer reduction, in terms of cardiovascular reduction, in terms of diabetes. The severity of diabetes have come down, the complications of diabetes have come down. Plenty of new information has come. But this is about the population which was largely non-vegetarian, which has shifted to vegetarian diet, right? And now this is a population in India which is completely, there's a good set of people who are completely vegetarian since birth, but there's a good relative prevalence of cancer is quite high in this population, which is as high as that of any of the Western population. Is it because of the processed food? Is it because of abundance of carbohydrate? Is it because of insulin resistance? There are hundreds of questions. We have more questions than answers, right, at this point of time. Otherwise, we do not know. India is an enigma. India is a very big enigma. We still have the infectious diseases of, the poor country. Still, tuberculosis is a problem. We have tuberculosis is a problem. We still have problem of infection. We still have problems of poor vaccination. The state that we are sitting in this year has slipped badly the vaccination implementation. So it is a not a very good situation to say that we can't even say that we are a developed country, or we can't say that we are really a good developing country amongst the top of the developing countries. No, we are somewhere in the middle of the developing countries, right, when it comes to some of these aspects. But when we look at the kind of diabetes that is coming in, the kind of cardiovascular problems that we get, the kind of cancer that we get, it looks like a highly affluent society. So we do have an enigma. We have a typical huge problem between all kinds of diseases. So conducting a genomic pattern and understanding is not that very easy in this population, but it clearly shows that soy milk, other than the animal milk, had some kind of an impact. This is a sort of an inference on the soy milk. Next slide. And dietary factors influencing DNA, plenty of them have a direct impact. Next slide. These are all various things that are well known. I will show you in the subsequent slides, which are the genetic receptors that are getting impacted. Next one. So this is one, again, a case control study and a cohort study. This cohort study, it's clear, breast fruits have had a good value, right? Lung cancer, fruits have really given good value. The bladder cancer, stomach cancer, right? So it was none of them had shown any kind of a greater risk reduction. The odds ratio has always been more on the positive side for the foods that are colorful, fruits and vegetables. Next one. So this is a little bit of a busy slide, I'm sorry for this, but it talks about the ligands and the kind of, the receptor sites. Next one. So some of it talks about the potential possibility of looking at the interrelated science without losing touch with the nature, and the way we have evolved, looking at the connections between the way we eat and our latest understanding, our technology of doing a genomic sequencing, and arriving at a value proposition for the future of the community. Next slide. So it's all about good lifestyle, good nutrition, and your, then you manage your genome well, ultimately. Next one. This is pretty well discussed by everyone. Yeah, next. Yeah. So the trend is, as we learn more, we could possibly be in a position to say what is good for you and what is good for the other person, although we are only 0.1% different from each other. With that 0.1%, what is the implications for each one is something that could possibly be of great value. Next. So this is ultimately the whole project is about possibly long term to look at what your genes like, right? And at least as a vegetarian, as a person who has lived through this, I have understood. I believe that the genes are more comfortable with the the plant diet with which we have evolved. Next one. So there is no specific study that we have from an Indian context about a whole community, and that's something which we may have to look at. Either we just thought about the Jain community because that's a staunch vegetarian community, at least for reasonable number of generations. So if we felt that Jain population could be a very good population to study for, right? But this is at an early stage, at a conceptual stage, to see what is the prevalence of various diseases as compared to the population in India, which is living in the same identical situations, and to see the variance and prevalence of diseases and health factors. That's where we look at. So, as I said at the beginning, the more we have, more we seem to have understood, the more we know that we have understood less, right? And we still have to understand a lot more. And this is a journey. This is something. Again, I like that Zen story, where one Zen saint goes to meet the other one, and the other one was cleaning the floor, sweeping the floor, and he asked, "What are you doing?" So the other Zen guru says, "I'm sweeping the floor." To what extent? To the extent possible. Then he says, "Is it before Buddha or after Buddha?" He says, "Somewhere in between." Right? The curious onlooker Shishya says, "What does this mean? What does this all mean?" I didn't understand. The story stops there. The story stops there. My own interpretation is, none of us are end of anything. None of us are beginning of anything. We are neither the beginning nor the end. We are a dot somewhere in that continuum which goes infinite line, and we do not know. And we are a dot, possibly somewhere in that line. And it's nothing wrong to be a nobody, right? It's not that you should be somebody all the time. It's nothing wrong to be a nobody, because everybody is nobody and everybody is somebody, right? So all of us have a journey to go forward. Thank you. Thanks for that.
Thank you, sir. Thank you, sir.